Welcome, ladies and gentlemen, to another episode of West Explains Best. We're doing some geometry today, proving triangles similar. Feel free to color this in if you guys have these notes, but we're going to be proving triangles similar today, not congruent. Let's learn the difference right now. First one up, angle-angle similarity, the AA similarity postulate. Okay, what does this mean? Well, we need to know two things. If we know that, let me get my Apple Pencil going here. If we know that, let's change colors, angle S is congruent to angle R, okay, we're going to start there, and then angle M is congruent to angle T. And it doesn't have to be specifically these angles, it just needs to be two angles, okay, we need to be given two angles. Then we know that, what? Well, we'll know that triangle SMA is going to be similar. That's the similarity symbol right there. That one is going to be similar to triangle RTY. And why is that? Well, the third angles theorem states that if these two angles are the same, then that means their third angle also has to be the same. And we know by similarity, the definition of similarity, that if they have three angles congruent, then that means the two shapes, the two polygons are congruent. So when we're talking about triangles specifically, all we need is two angles given. We know the third angle is going to be given, and the triangles are going to be congruent. So pretty cool there. All you need is two angles to know that triangles are similar. Next up, we have side angle side similarity. Okay, so first off, we need to have a proportional relationship here. We need to know that the scale factor between this side and this side, all right, and then this side and this side. Notice how the two sides are touching, okay, and they form a vertex where they touch. That green, actually, let me make it purple. I think that'll be more clear. And that's where they touch, the vertex. This has to be the angle that's congruent. So angle, hold on a second, SM, RT, SA, aha, perfect. So there's a mistake. Get your white out, okay, if you want to. I can erase, but I don't think those with the notes can. Get your white out. It's not angle A that's going to be the one. It's going to be angle S. And why is that? Angle S. It's because it has to be sandwiched between the sides, okay? So the given angle has to be sandwiched between the side and the other side, side, angle, side. So angle S needs to be congruent to angle R. That would make the sandwich side, angle, side, so it's not angle A. Okay, kind of good that we went over that distinction. Has to be between the two sides that are similar in scale. So this has to be proportionate. So whatever we multiply here, let's say this is a scale factor of 2, and this is a scale factor of 2. Okay? Then that's what we need. We can't have one have a scale factor of 2 and the other one a scale factor of 3. Okay, so if we take this side, and let me give you some numbers, this might make it a little bit more clear. If this is side of 10 and this is 2, and this is side of 12 and, let's do 15. And this is 15 and this is 3. We know that we multiply by 5, that's similar, and then we just need to know that the angle in between is congruent and that these two triangles are going to be similar. So now we can finally state that triangle, what color did I use last time? Green, okay. Now we know that the two triangles, SMA is going to be similar to triangle RTY. RTY. Okay. Sorry for the confusion with the angle A there, but I'm glad we caught our mistake. Make sure to change that to angle S, not angle A. It's got to be sandwiched between the two similar sides. Last one, side similarity, SSS. This just means that we need to have all the sides proportionate. They need to have the same scale factor going on. So let's go ahead and highlight here. So SM needs to be similar to RT, SA to RY, and then MA to TY. Thank you. TY. Okay, so let me go ahead and finish that highlighting just so you can see exactly what sides we're talking about. They just need to be the same sides. And you'll know which sides are the corresponding ones. So once we get this, we know that the two triangles are similar. And let's name it something else. We're going to call it MAS this time, similar to, and let's keep the order same, TYR. We can change up the order. Same name, or same triangle, different name. Are the triangles similar? For example, 1. If so, write a similarity statement. Okay, so first up, we are only given side lengths. Okay, so what we're going to try here is we're going to try SSS. We're going to see if this is true. And this is what I was talking about. You'll know which sides to compare. Well, if we're going to be comparing similar sides, we should start with the biggest side and compare it to the biggest side of the other triangle. And then the medium to the medium, and then the small to the small. Okay, and we're going to compare all three of those. So we're going to take our biggest side first. So this is our big. We're going to go the large triangle over the small triangle. So the big triangle is 15 for the biggest side, and then we have the small triangle with 10. Is this equal to the medium side, 8 over, we want to go with the large triangle on top, so that's 12 over 8. And then finally we have 9 over 6. Okay, and that's for the small side, the shortest side. All right. What we need to do is we need to reduce all of these and see if they are equivalent. Look for a common factor. Here we can divide by 5, and we get, 3 over 2. We can divide by 4, and we get 3 over 2. And then we can divide by 3 and divide by 3, and we get 3 over 2. So guess what? It's the same ratio each time. Therefore, these are similar by side similarity. And that's how you do these types of problems. So we applied this, and now you see that we just compare each of the sides, making sure we compare the largest, small with the smallest, and so on. Example 2, we have some overlapping triangles. Okay, so anytime you have this situation, I would encourage you to draw out the separate triangles. So I'm going to draw my small one in blue, and we'll go my big one in purple. Okay, so here's my big one. Okay, I did a great job drawing those two triangles. Just saying. Now what I like to do is I like to separate it. So I'm going to separate it into the small one, and I'm going to redraw the dimensions. So I know this is 8, I know this is 12, and then I have an unknown side there. And we might not even need it later, but I'm just keeping it blank for now. Let's go to the big one. Okay, so my big one looks like this. Same thing. Okay, it doesn't have to be perfect. Now, this side, we got to figure out. So we have an 8 and we have a 2, so that is going to be 10. Same thing with the bottom side. We have to figure this guy out. We have 12 and 3, that's going to be 15. And again, we don't know that last side, but I don't know if we need to. Now, it looks like we only have 2 dimensions given. So what do? We only have side and side. We need an angle or an additional side. We already know that the other side's missing. So maybe we can look for an angle. Is there an angle that they have congruent? Anytime you have overlapping triangles, usually you're going to have angle that's congruent, and in this case it's here, it's in the corner. They both share this angle. Okay, and if I were to grab this guy and then move him over, you'll see that. Okay, so I didn't do a great job drawing the exact same angle, but I hope you can see that as it was like this, it had the same angle and we just separated it out, but those angles are congruent. What does that mean? That means it's side angle side potentially. We know the angle's congruent, that's a good first step, but now we need to know, are the sides congruent? So we're going to compare our big side of the large triangle to the small side of the large, well, hold on. We can do the big triangle with the long side and the short side. Okay, so we're going to see if those are the same. So the big triangle, here, it'll make sense, sorry. Trying to stay organized. So the big triangle has a long side of 15 and a short side of 10. Okay, and I'm going to compare it to this small triangle. The small triangle has a long side of 12 and a short side of 8. And I need to know if these are the same. Okay, I'm going to reduce. So I divide the top one by 3 and 3. and I get 5 and 4, and I divide by 2 and 2 here to reduce, and I get 5 and 4, and it's the same, okay? Once it's the same, now we can say that it is side, angle, side, similarity. And these two triangles are similar, okay? That's it for now. I'm going to get into two proof examples. Well, this one's not a proof, but a nice little problem. I'm going to get this into part 2, so if you want to check that video out, stay tuned. But thanks for joining. I hope you enjoyed the video.